This is the CAPS Dbe Nsc question 2 of the 2022 November paper 1. The first term of a geometric series is 14, and the sixth term is 448. So T1 is equal to 14, which is equal to A, and our T6 is equal to 448. We know it's geometric, so Tn is AR n minus 1. That means if we take T6, it'll be AR n minus 1, 6 minus, n is 6, so 6 minus 1, so AR 5. Our T6 is equal to AR 5. We also know that our T6 is equal to 448, so we can immediately deduce that 448 is equal to AR 5. From there, it was given that A is 14, so we sub in 14, and we get 448 is equal to 14R5. Divide both sides by 14. 448 divided by 14 is 32. To get rid of this 5, you take the fifth root on each side. Fifth root on each side. So our R will be equal to the root of 32, which is 2. One point one was to find R. We found that R was equal to 2. 2.1.2, determine the number of consecutive terms that must have been added to the first 6 terms of the series in order to obtain a sum of 114,674. Now this question has sort of weird, but first to unpack consecutive terms that must be added to the first 6 terms of a series. So the first thing I see is series. That means we're finding the sum to n. So we can say that the sum to n is equal to some sort of sum to n that we don't know, plus the sum to the first 6. So if I just look at the wording of the question, the sum to n, the final sum to n, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of this. So it's saying how many extra terms must be added to the first 6 terms in order to get the sum to n, which is 114,674. For me, the first step here would be to figure out what S6 is. So S6, we're working with a geometric series, so we have our geometric sum to n formula. We already know our A and our R values. Our A value was 14 from the previous question, and our R we worked out as being 2. And n is 6. 2 minus 1. This just goes straight into your calculator, a little bit of calculator work, and I get the answer of 882 for S6. When I get to this stage in the question, I start to ask myself whether this will even be helpful to get my final answer, so just leave that there. The next thing I want to know is, what will the final n be? So if we have Sn, what will our final n be? Well, using our geometric Sn formula, we can sub in the values we know, which is 14. Our R was still 2. We don't know what the n is. This question is just asking, what will our final n be? And we're going to sub in the final value that was given, which was given as 114,674. 114,674. I'm going to ask the math, what will our final n be? I'll quickly just finish this up. 114674, 114174 is equal to 14, 2 to the power of n minus 1 over 2 minus 1 is 1, so we can drop that straight away. 114674, divide both sides by 14. 114674, 114. Nice number of 8191. 8191. 114674 divided by 14. We don't need these brackets anymore, so we can plus 1 to both sides, so it'll be 8192 equals to 2 to the power of n. We want n as our subject, so we're asking what n is. What is n? So a to the power of b equals c. We use the log law, log ac equals b. So log 28192 is equal to n. This goes straight into the calculator. So n comes to an even number of 13. So there's 13 terms in our Sn when S13 is going to be equal to the given number that they gave us of 114674. So I see that I didn't really need this working of S6, because we can just deduce straight away from here, if S13 is equal to 114674, looking at that 13, we just take away 6 from that 13. 13 minus 6 is 7. We're going to need 7 more terms. 7 more terms. Let's just check the question. It says, how many number of consecutive terms must be added to the first 6? Another 7 terms must be added. Right, so the previous question was actually fairly straightforward. You just had to find S13 and then minus 6, the first 6 terms, so there's 7 consecutive terms. 2.1.3, the first term of another series is 448 and the 6th term is 14. Calculate the sum to infinity. Let's start getting this down. So T1 is 448, which is the first term, so equals to A. And the 6th term, T6, is equal to 14, the 6th term. This sum to infinity formula is for geometric A over 1 minus R. We can already see, since it's geometric, that T6 is equal to AR n minus 1, which is 6 minus 1, which is AR5. We know that T6 is equal to T6, so we can immediately say that 14 is AR5. But we were given that A is 448, so 14 is equal to 448 R5. So now we have divide 14 by 448. Divided by 448, and we can take the 5th root of both sides in order to cancel out that 5. It's in the calculator. So find this is the second function of this, so it's above that to get the 5th root. Press shift and then this button. Add 5 there, and you can straight away put 14 over 448. R comes to a half. Right, so the requirements of the sum to infinity is that your R must be a fraction, so between -1 and 1, and not equal to 0. So we've met the requirements. So all we have to do is take our sum to infinity. We know that our A value was 448. And we know that our R value is a half. And then we have sum to infinity, A over 1 minus R. We can use in the calculator, 448 over 1 minus a half is 896. That concludes 2.1.3. Number 2.2, the sigma sign shows us that we're doing the sum to n. So they're saying if the sum to n is equal to 20 and 1/6, what is our k? So looking at the way that this works, you sub in values of p, you start with whatever p is equal to, you sub it into the function they give you. What I do with these sorts of questions, immediately start listing 3 terms so I can analyze what kind of function they've given me. 1 over 3, I sub in p is 0. T2, 1 over 3, you just keep counting up. And T3, so 0, 1, 2, the first 3 terms. A little bit of calculator work. This, anything times 0, 0, so this one is just equal to a 1/6. This is 1 over 3 plus 1 over 6, so it would be 2 over 6, so it would be 3 over 6. This one is 2 over 3 would be 4 over 6, so it would be 5 over 6. We have 3 terms, 1 over 6, 3 over 6, 5 over 6. Then I analyze the terms. I say, well, does it have a constant R, or does it have a constant difference, or what is the, a common ratio or constant difference? To me, it looks like it's going to have a constant difference. So in order to find that out, you take T2 minus T1. So T2 minus T1 would give you D. So 3 over 6 minus 1 over 6 is 2 over 6. And then we do the same here, T3 minus T2 will give us D. So 5 over 6 minus 3 over 6 is 2 over 6. So we see that they're the same. D equals D, therefore this is actually arithmetic. So we can assume it's arithmetic. Another way you could have seen that this was arithmetic is actually that this is, if you look at the formula, it's in the general form of the straight line. So that also could have given it away. But I find doing 3 terms is a much more solid method. Okay, so we have an arithmetic sequence. It's asked for the sum to n is equal to 20 and a 6th. What is k? K represents the last p-value, that gets subbed in there. So just, it's the last term, but k is not going to be the same as the last n. So just to be aware of that. But let's take a look at the sum to n. So we know that our sum to n is equal to 20 and 1/6. We need the arithmetic sum to n formula. This is n over 2, 2a plus n minus 1b. Our D already. Our D was 2 over 6, which is 1/3 when it's simplified. And we don't know n, but we do know that we have Sn, Sn, therefore we can sub in 20 and 1/6 where the Sn is. 20 and 1/6, obviously not to be confused with 20 times 1/6. This is 20 plus 1/6, this is 20 and 1/6. So we should just put that in improper fraction is 121 over 6. let's just check that, 20 plus 1/6 on the calculator. Yes, 121. 121 over 6 is equal to n over 2. Our a value was our first term, which is a sixth. Don't yet know what n is. That's what we're trying to figure out. And we know that our d is a third. First thing, we want to rearrange this a little bit. We times both sides by 2 to get rid of the 2. So 121 over 6 times 2 over 1, the side that 2 is gone. We cancel out, cross cancel these. It's just going to be 121 over 3 equal to n 2 over 6. 2 times 1 and 1 times 6. Plus 1 over 3 n. 1 over 3n is just n over 3. And this is 1 over 1. So it will just be minus 1 over 3. Last step. Just want to times in this n. So we have 2 over 6 is just 1 over 3. So 1 over 3n simplified. And then we have 1 over 3n squared. So n times n is n squared, and 1 over 3. It could be n squared over 3. So I just choose to put it in this form. And then 1 over 3 minus 1 over 3n. All right. I see we got very lucky. This cancels out. So we have 121 1 over 3 n squared. This up very quickly. 121, these denominators are the same. So n squared is equal to 121. We can take the square root of both sides. When you do your own square root, make sure you add plus or minus, but just note that n will be positive because you're working with a counting number. So n is actually a position. Square root of 121 is 11. So n is going to be equal to positive 11 because n is actually a position. Now we go back to, we had, the question asked us, what is k, not what is n. So usually there'd be an n in that position where the k is. Usually there'd be an n there, which represents the n, the position of the last term. But in this case, we're subbing in values, and they didn't start on p equals 1. They started on p equals 0. So our first p value was actually 0. So if we start on 0 and we count 1, 2, 3, etc., we actually end up with our last k values, which is p, the final p. Our last k value is equal to 10 because the 0 took up one space. And that concludes question 2. Please like if you like and subscribe.